Okay, hello everybody. My name is Anthony Kyriakidis. I work in the Scottish Renewables team at the Energy Saving Trust, and welcome to today's webinar. We're going to be focusing today on home solutions for historical and hard to treat homes. And I'm delighted that we're going to be joined by Moses Jenkins. Moses works at Historic Environment Scotland, and he's their senior technical officer there. He's been working in this sector for many years and is essentially a guru on this type of thing, so it's great to have him on board. We're also really pleased to have Julie Darling joining us today. Julie is a homeowner, Scottish homeowner, who's also a member of the Green Homes Network. The Green Homes Network is a network of people in Scotland who've made improvements to their homes and are happy to share their experiences with others about what they've done. The webinar itself is a part of a series of webinars we're delivering. The work's funded by the Scottish Government as part of their support for home renewables and energy efficiency in homes. And all of that programme of work is really there to help Scottish householders lower their energy bills, their carbon emissions, and meet climate change targets, as well as build a lower carbon economy. Some general points about the webinar. If you've not attended one of these before, you can hear us, but we can't hear you, and that's perfectly normal for webinars, so don't be concerned. We're also recording it, and we'll send you a link to it afterwards so you can watch it back. It'll probably last about 45 minutes, and if we get time towards the end, we'll try and answer any questions you've sent through. You may see in your webinar software that there's in the control panel, which is normally on the right of the screen, you should see a section there where you're able to submit questions to us. So really, without further ado, I want to pass you over to Moses. Thank you very much.
So what I want to talk about is ways that we can look to make buildings which are of traditional construction, so our older building stock. I want us to look at ways that we can make those buildings more energy efficient, ways that we can make the fabric of the building essentially lose less heat. Now, we'll go on to look at insulating walls and floors and roof spaces and improving windows in a little while, but first it's important that we consider for a while why we need to take a different approach when we're improving energy efficiency in an older building, so a building of traditional construction, than we would if we were improving a modern building's thermal performance. The reason why we need to treat buildings of traditional construction differently is essentially down to how moisture moves within the building fabric. Now, if we think of a building of traditional construction with thick mass masonry walls, generally about 600 millimeters thick, constructed of stone or brick, held together generally with a lime mortar. Such walls are what is often termed breathable. Now, what that term refers to is the way in which masonry walls of traditional construction handle moisture. And in essence, what this means is that moisture can go into the fabric of the building and it can leave the fabric of the building again. So moisture that we produce within our homes, perhaps through cooking, perhaps through showers, drying clothes, all of those activities create moisture within our homes. And in a building of traditional construction, what happens is that moisture can enter into lime plaster, it can enter into masonry, it can enter into lime mortar and timber, all the materials which make up our traditional buildings. It can go into that and it can come back out again, it can diffuse back out. And that dynamic is absolutely crucial to how our traditional buildings work. And we must always have that in our minds when we are making improvements to energy efficiency. So you can see from this slide some of the sources of moisture which I have just referred to. So external source of moisture, we have rain. It rains a lot, it will rain more as climate change takes hold. So when rain hits the external surface of a masonry wall, that moisture can enter into the wall and it can diffuse back out again. And the same happens internally. So all of these activities, the moisture that those produce, enters into the wall and it diffuses back out again. That is how masonry walls of traditional construction work. This is the movement of air around our traditional buildings. Now the slide, which you can hopefully all see just now, is illustrative of the thought process behind air movement within traditional houses. So essentially you have subfloor vents. It rises up, it gathers the warm, moist air that we produce within our homes. That rises up and generally diffuses out through the roof space. And those two dynamics, whereby we have the movement of air and we have the movement of moisture, those two dynamics work together to ensure that moisture levels within the building fabric are kept at a safe level that isn't going to result in excess condensation and mold growth and timber decay and any of those type of problems. Because it is problems that we risk creating if we don't handle air and moisture movement correctly within a traditional building. So if we take an approach to energy efficiency that involves restricting the movement of air excessively, if our approach to energy efficiency involves restricting the movement of moisture, then we do risk creating the conditions where condensation will form, and that liquid moisture can then lead to mold growth and timber decay and other issues such as that. So we need to be careful how we approach energy efficiency within traditionally constructed buildings, and we need to avoid creating problems. There is, though, a lot that we can do. There is a lot that we can do to make the fabric of traditionally constructed buildings more energy efficient. If we think firstly about insulating walls, so if we think about insulating solid mass masonry walls, when we think about internal insulation, we have looked at three broad approaches for insulating masonry walls internally. If there is a wall lining built off the masonry, so it could be lathed plaster, could be later plasterboard, look at putting material into the space between the wall lining and the masonry. We've also looked at putting a material directly onto the masonry, so no gap, just an insulating material applied directly onto the hard, onto the masonry. And thirdly, we've looked at building out a frame, putting in an insulating material, and then finishing with plasterboard accordingly. So if we look at each of those three in turn, think firstly about putting something into that space between a wall lining and the masonry. We've looked at various different materials for doing this. Now, in the next little while, I will talk a lot about U-values. And a U-value is essentially a way to express how much heat passes from the inside of a building through a building element to the outside world. And the higher the U-value, the more heat passes through that wall or window or roof or whatever it is we're talking about. In general, a mass masonry wall in Scotland will have a U-value of about 1.1 or 1.2. That's a broad average. And by putting this material, which you can see in the slide, into that space between the wall lining and the masonry, we got that U-value down to 0.3, which is a good improvement. We were happy with that. Some caveats though with this material: it needs to be kept isolated from electrical wiring So the areas of repair that you can see, the darker areas on the wall finish there, that's where we put electrical wiring into a conduit. That's an important detail to get right. Another caveat, you may well find there is a gap at skirting level where the floorboards meet the skirting. You'll need to pack that out with something, or you will stand there for a long time wondering where all the beads are going. The answer is they'll be filling up the void under your floor. So that's another little detail to get right. And lastly, if you're putting anything into that space, you need to think carefully about air movement within the roof. If you're reducing the amount of air which is going up into the roof space, is there enough ventilation to keep everything well ventilated, a good flow of air? And if there's not, you might need to think about slate vents to keep that roof space well ventilated. Another material that we've looked at in this type of situation is putting in an open cell foam into that space between a wall lining and a masonry wall. What you can see in the picture there is an open cell foam. It's important to get the differentiation between an open cell foam, which allows moisture to pass through it, and a closed cell foam, which does not. So if we're thinking about allowing moisture to move freely, it would be an open cell foam that we would want to use. Now, if there is no wall lining, then you can apply an insulation onto masonry. And that's what you can see in this picture here. Calcium silicate board getting applied directly to masonry. It's stuck on with adhesive mortar, which you can see. That's the brown stuff which is on the wall. The calcium silicate board is then stuck on and finished with 2 coats of plaster. About a 50% improvement in thermal performance by doing that technique. The computer's telling me my battery is running low, so let's see if we can fix that. That should be us. So about a 50% improvement by doing this technique. Another material that we've looked at, which is applied directly to masonry, is aerogel blanket. Now, aerogel blanket is a very thin material. It's only 10 mil in thickness. It's flexible, so it's very good in situations such as you can see in the picture where we insulated a stairwell in Rothsay. And the aerogel blanket was ideal because it was thin, so it didn't take up much space, and it was flexible, so it was easy to apply to a curved substrate. Good level of thermal improvement, as you can see from the U-value. The issue with aerogel is the cost. It's about £70 a square metre. So if you have a flat area of wall and plenty of space to work with, aerogel blanket is probably cost prohibitive. But where you don't have much space or you have a curved substrate such as we had here, it's a very useful material indeed. Now, the third approach for insulating internally is to build out a frame and put in an insulating material that way. And what you can see in the image there is hemp fibre board in place. Good level of thermal improvement down to 0.21 of a U-value. And same approach, different material, this time using wood fibre board insulation. And in that case, that's one of our site projects in South Uist. In that case, we got the U-value down to 0.19, which is a very substantial improvement in thermal performance indeed. Always remembering, with all the materials which I've looked at in the last 5 minutes or so, all of these materials allow moisture to pass through the insulation, diffuse into and back out of the masonry behind. And that is very much the approach which we take when we're insulating mass masonry walls. Just thinking about, for a little while, about external insulation, we have looked at using wood fibre board externally as an EWI, an external wall insulation. You can see it in the picture there. It's applied directly to masonry using thermally decoupled expansion fasteners, which are the little white dots that you can see there, which are plastic fixings that go over the screws to avoid thermal bridging. So it's applied directly to the masonry, it's covered, it's finished with 2 coats of render over the top. Again, all of this allows moisture to move freely through the structure. You can see there a detail of the render system which is used as a finish. The U-value improvement there, 1.3 down to 0.4, which is a good level of improvement indeed. However, we have to bear in mind when we're thinking about retrofitting external wall insulation that detailing can be very complex indeed. You have services, windowsills, roofs, downpipes, vents, porches, all sorts of awkward details that need to be considered. And it's not to say that you could never put external wall insulation onto a traditional building, but we do have to make sure if we're going to do that, that all of that detailing is taken into account. If we turn away from walls now and have a think about windows briefly, an unimproved single glazed window has a U-value of about 5.4 or thereabouts, and it's important initially to recognise that existing options that you may have in the home, such as shutters and blinds and curtains and all of that sort of infrastructure, can make a significant improvement to the thermal performance of a window. So we've tested that in situ and it does make a significant improvement. So if you have shutters, please use them. If the shutters have been nailed to the wall, please bring them back into use. They are useful in terms of thermal performance. If you want to make a more substantial improvement, a more permanent improvement, if you like, to the performance of the windows, you can look at secondary glazing. Various different systems out there, you will achieve a thermal performance probably of around 1.7 of a U-value. Now that will vary depending on the system that you use, but that's a broad average. Feedback generally indicates that people like secondary glazing, which can be opened and closed. So that's perhaps a detail to bear in mind. And in this slide, you can see a summary of all the different improvement options which we have looked at as part of our site trials. And you can see right at the top, if you have space for secondary glazing and shutters, and not everybody does have space for that, but if you do, and you can get all of that working well, you can make a 75% improvement in the thermal performance of single glazed windows. If we think now about lofts and roof spaces, a loft is generally it's one of the easiest parts of a building to insulate, to make a thermal improvement to. We've looked at sheep's wool between ceiling joists. You can see the level of thermal improvement on the slide there. We've also looked at putting wood fibre board into that space between joists, which gives a slightly better level of thermal improvement, but is a bit more awkward to work with in that kind of situation. So there's a consideration there. We've also looked at situations where you perhaps have a room in the roof, so that's quite common in rural areas in particular. And the image that you can see on the left there, where the ceiling linings were still in situ, we removed sections of the ceiling lining. So the blue section is the pitched part of the roof, the white section is the upright section of the roof space, and we simply removed sections of that lining. We put wood fibre board into the space, making sure though that we left a gap on the other side between the insulation and the sarking board onto which slates are nailed to allow air to flow, to continue to ventilate the sarking board. So again, an important detail to consider. With all of this work, and I keep going back to it and I will continue to do so, we must always think about air and moisture movement, how the work that we do will affect that, and take steps to minimise the chances of any defects arising. as I say, absolutely critical to think about air and moisture movement. So if you are filling up spaces, if you are putting insulation into a gap, make sure there is enough of a space between that insulation and the sarking to let air flow and keep that sarking board well ventilated. Otherwise, we create conditions where condensation will form. Condensation, liquid water, that will potentially feed mold growth, and that's what we have to try and avoid. I just want to briefly touch on insulating floors. Now, if you can get underneath a floor into a crawl space, then you can insulate between joists, although that can be quite an awkward area to work in. So alternatively, you can put the floorboards, put timber runners down, which is what you can see in the inset picture there, and then place something such as a wood fibre board or a hemp fibre board onto those runners. You can see there from the Uvalue improvement that you can make a significant difference to thermal performance of a floor by doing that. And that is really all I want to say for now for my part of the webinar. Just by way of conclusion, again, I want to stress that the idea of moisture movement, of air movement, of ventilation, that is absolutely critical to any work which we do to make a traditional building more thermally efficient. Now, we can improve all parts of traditional buildings. We can make the windows more efficient, we can make the floors and the roof spaces and the walls, we can make them all perform better thermally, but the work has to be carried out with sensitivity, and that's both an aesthetic sensitivity to how the building looks, but also it must include a sensitivity to how the building performs. Now, what I have covered in the last 20 minutes or so is a very quick run through what is a very complex subject. So I would encourage everybody that's listening today to look at the material that we have on our website. We have case study buildings, we have a short guide to this, and we have technical papers, all of which provide the evidence base which has underpinned what I've talked about today. So if you go onto the Historic Environment Scotland website and find the technical research publications section, you can look at all of that. So I'm going to hand back to Anthony now, if I can get the technology to work. So hopefully soon it'll pass back to Anthony. I hope everybody's found that interesting. So that's all from me.
Okay, thank you, Moses. That was excellent. We did have a question come in now, and everybody, if you're there, then remember you can ask questions as we go through, and we'll try and answer them. The question we've had so far, Moses, was to do with EPCs and what is the impact on EPCs from the various types of improvements you've gone through.
Can everybody hear my answer to that? Can everybody hear me?
Yeah.
Yeah, good. The answer to that is it varies from building to building, and in some ways from between different assessors how they rate the various improvements. What I would say with regards to EPCs is we need to be careful how we use those in relation to traditional buildings, because often they will suggest that the performance of a building element is worse than it actually is. So for example, an EPC assessment will often ascribe a U-value of 1.7 to a mass masonry wall, whereas in reality it may be closer to 1.1. Now that has implications if you are going to try and work out how much money you're going to save, because you may well not save as much as you were expecting if the assessment is based on data which suggests that the wall is performing worse than it is in reality. So we have to be a little bit careful about that. And what I would also say in the context of EPCs is that often the measures which are suggested by an EPC to bring the banding up to improve the performance of your building, they may not be what is best for the building in reality. So please think carefully about how the building works, how it performs, and make an informed choice about energy efficiency from a position of knowledge yourself, not just based on what an EPC assessment says.
That's great. Thank you very much. We've got some other questions coming in. I think we'll take those at the end, because
yeah, sure.
What I'd like to do now is just quickly run through some of the support that you can get through Home Energy Scotland, and also introduce Julie. So we work closely with Historic Environment Scotland on the work that we do. And part of the work we deliver on behalf of the Scottish Government is through Home Energy Scotland. That provides independent, impartial advice funded by the Scottish Government for homeowners about how to improve the energy efficiency of their homes. And as part of that, there are specialist advisors who can provide you that advice either in your home or remotely. And those advisors, those specialist advisors, are based all the way across Scotland, so there should be someone who's reasonably local to you. And that support service, which is free and funded by the Scottish Government, that can include a visit to your home and a report afterwards. And it covers not just energy efficiency improvements, but also renewable systems as well, which we're going to touch on when I introduce Julie. We support about more than 3,000 households every year with that specialist support, and pushing on towards 100,000 households every year just across the range of Home Energy Scotland activities. There's also financial support. So if you're thinking about making improvements, then get in touch with Home Energy Scotland, and they'll tell you what you may be eligible for. On the energy efficiency and renewable side of things, there's a loan from the Scottish Government called the Home Energy Scotland loan. That's an interest-free loan, and you can get over £30,000 worth of interest-free loan funding for renewables and energy efficiency improvements. If you just want to do one or the other, that's allowable as well within certain conditions. And with the loan, that helps you with the initial costs. If you're installing a renewable system, there's other support available as well from the UK government, and you can combine this with the loan from the Scottish Government. So there's something called the feed-in tariff scheme. That is where you get paid for using a renewable electricity system, putting one in your home and generating renewable electricity. So for example, a solar PV panel or a wind turbine. So that's for renewable electricity. And for renewable heating, there's something, support scheme from the UK government called the Domestic Renewable Heat Incentive. And it works in the same sort of way. You will get payments from the UK government via Ofgem, who administer it, for a number of years for installing that renewable system. There are also other schemes that are available, and that's why it's essential you speak to Home Energy Scotland, so they can work through what support you could be eligible for and which are the things that may not be the right thing for you. There are other things available. So there's the Green Homes Network, and I'll introduce Julie in a second, but this is essentially a network of householders across Scotland who have made improvements and are happy to chat with you or allow you to come around and have a look at what they've done. And if you're specifically looking for renewables installers, then there's a renewables installer finder on the Energy Saving Trust website as well. So I've just put the number here for Home Energy Scotland too, if you want to take it down. It's 0808 808 2282. What I'd like to do now is introduce Julie. So Julie is one of our homeowners on the Green Homes Network. She lives in really quite an old farmhouse. It was built in the 1850s and struggled to stay warm in that farmhouse, and looked at a number of things that could be done there to improve sort of the comfort and well-being within that home. So what I thought we'd do today is just ask Julie some questions. So firstly, I wanted to say, Julie, what was it like when you first moved into that home and living there in in the way it was as when you moved in?
Hello. Yes. Well, it was very, very cold. We had a couple of open fires and a solid fuel-fired Rayburn that was in the house. But the bedrooms, they had radiators, but we really weren't ever able to get any heat into them.
Yeah. And what was it? I mean, what was it like, sort of living in those sort of conditions, particularly over winter?
Freezing, in a word.
Okay. And I mean, at which point did you make the decision that you needed to do something about it?
Well, we did make improvements slowly over the years. I mean, I think we thought, well, probably, well, no, sorry, we started with a bigger and better wood-burning stove that had a back boiler, but we think we were sort of oversold that. It never really heated to the level that we thought that it would have done. And then the next step was to put secondary double glaze. We have lovely old windows in the house that we didn't really want to replace. So we had secondary double glazing installed, and that made a big difference. That helped a lot. I mean, obviously, we did all the things like insulate the loft and draft. Husband put draft excluders around all the doors, and we tightened everything up just as much as we could. Underfloor insulation, well, we still dream about doing that, but that would just be such an upheaval. We haven't quite got up to that. Can't get motivated to do that. So yeah. So secondary double glazing, and then this we've learned about this loan that was available for the pellet boiler, and that just seemed the perfect solution because we're way too far away from any kind of gas mains. Oil was very expensive at the time, so we got the pellet boiler.
Okay. Yeah. Yeah. I mean, and that's something that I think lots of people will be interested in. You know, what was the thinking behind going for that particular system in the property that you've got?
Well, I mean, we were freezing still, but also I think we wanted anything we did, we wanted to do our bit for, protecting the environment. And I hope we've made the right choice with the pellets. I hear kind of mixed things now about pellets, but we thought that a biomass boiler would be much better than any sort of fossil fuel solution.
Hmm. Yeah. I know one of the common questions that people have with like a wood-fueled system, whether it uses logs or whether it uses pellets, is about where to actually store that fuel. So how did you sort of overcome that?
That's not really been a problem. We have space in the garage, so we get a ton of 10-kilo bags delivered at a time. We had the boiler installed inside our house because well, we had space for it, and we really wanted to get every single calorie or whatever the measurement of heat is. We wanted to get every single bit of heat that was produced into the house. So we have a space in the house for about 20 bags, and the rest of them are just out in the garage.
Okay. And I know you've mentioned before about sort of the concern about sort of problems with lifting the bags, because they do, as you said, they come in sort of 10-kilo sort of quantities. I mean, what's that been like living with that and using it?
Well, no problem at all. I'm 62 and my husband's 76, and we manage just fine. I suppose we look on it as another form of exercise, maybe, I don't know. But I mean, it may be that someday we'll have a problem, but we can always, just shovel them in. I suppose if we live to be 100, teaspoonful by teaspoonful, but it's not a problem at all, really.
Yeah, well, I guess that's an important point, that in that some people may consider the bag too heavy to lift, but you're absolutely right. You don't need to lift the entire bag. You can take them through as and when, or in quantities that you think sort of suitable for you.
That's right. I mean, yes, that's right. We could have got. I mean, I think a lot of people think pellet boilers have to have this complicated automatic feeding system, and that means building something outside the house. As far as I know, I don't really understand it too well, but you have to have a hopper outside, and then it's vacuum fed, and that just seemed to us very complicated. But that would if we had gone that way, then we wouldn't have to think about feeding it manually.
Yeah. And do you typically need, with a property like yours, do you typically need to use any of the heating during summer, or is it mostly just really for hot water?
Yes, that's right. We had it off. Well, we've only just maybe a month ago put the heating back on. So the heating element, the domestic heating, was off all summer, and it was just really for hot water. Yes.
Okay, and I mean, how often are you having during the winter season, the sort of heating season? How often are you having to fill it with pellets?
In the winter, in the coldest part of winter, probably every couple of days. So that's about 7 bags. Last us a couple of days. We've got 5 bedrooms and a couple of other rooms, so it's there's quite a lot of space to heat. We've got three adult children who come and go, but that's showers and heating. That about does us.
Yeah. And I mean, with the Scottish Government loan that's available and also the renewable heat incentive from the UK government, there's been a big increase in the number of people looking at renewable heating systems. And with that has sometimes come an increase in the number of people installing them. So how did you go about trying to find somebody?
Well, we definitely looked at the list of people who were listed by the Energy Saving Trust. And that worked out fine. We got some very good quotes, and we were delighted with the people who installed it in the end. So that was all easy, actually.
Yeah, and that's a critical piece of information we try and tell everybody, is that try and get a number of quotes from different people and look at their various solutions for your sort of specific property, because getting that range of options is always important.
Yes.
So having sort of lived with the system for a while now, Julie, what have you found for the costs of running the system on sort of an annual basis?
Well, yeah, people often say, how much are you saving? We have, in our situation, we're not saving anything because we never really had a proper heat source before. So we're actually spending now money on heating where we didn't have to before. So we're probably not very good people to ask about how much we're saving. Yeah, my husband just saying here we were chopping wood and keeping warm that way, and it was all free. So this is a new expense in our lives, but my goodness, it's great to be warm at last.
Yeah, I know that sort of come across quite strongly, and when sort of the information you've at least put in your case study as well about now being comfortably warm in your home.
Yeah.
I mean,
Yeah.
what sort of difference has that made to how you can use your home?
Well, we just feel like we've joined, the rest of the world. We're living in the 21st century now, and we can go around without coats on in the winter. We don't have to issue all of our visitors with shawls and hats for them to keep warm while they're eating dinner with us.
Okay, that's great, Julie. Thank you very much. And hopefully there's lots of information there that people can take away with them and thinking about what to do in their own homes. We have had some questions in. Just having a quick look through them now. So there's some more specific questions, and this is probably more for Moses. We'll just unmute you, Moses. There's somebody asking, saying that they've got an early 19th century cottage. It's constructed with rubble stone, and the owners are slowly improving it. There's sort of a lime mortar and field stone, but they said one of the issues they've got is that the external render is cementitious and was applied around 1940. So how does that potentially affect the property when applying internal wall insulation, that particular render?
Well, if there is a cement render externally, then that has the effect of restricting the ability of the wall to allow moisture to dissipate. So if you think of the masonry wall, moisture will get in because moisture always gets in to the wall, but when it tries to evaporate, when it tries to dissipate out to the external environment, it will come up against the cement render, which is impermeable to moisture, so it won't allow the moisture to dissipate out, and it will be a lot harder for that wall to dry out. Now, how that affects insulation is that at present it is likely that moisture will enter into the wall and it will diffuse into the internal environment. If you change the dynamics of that wall by insulating it, if you use an impermeable insulation, so an insulation which doesn't allow moisture to move, that could have the effect of meaning that moisture can't get outside because of the cement, and it can't dissipate internally because of the insulation. So I would say if you are considering insulating internally, please think about a material which allows moisture to move freely, and also think carefully about how much insulation you put on, because if that wall is struggling to get moisture out of it, if you lower the temperature, you raise the chance of condensation, which can then make the wall wetter, which just perpetuates that situation of a wet masonry wall. So think carefully about how you insulate the walls, think about moisture movement, and if the render externally is failing in any way, you may want to think about taking it off and replacing it with a lime-based alternative.
Okay, excellent. Thank you, Moses. And we've probably got time for just one last question. This person's asking about the depth of insulation. So they're saying, bearing in mind the thermal profile of a wall, what's the maximum width or depth of insulation that can be installed to a wall without creating interstitial condensation from the reduced heat that is then going into that wall?
Yeah, the depth of insulation would depend on the material used, because different materials will lower the insulation of the wall to a different degree. The lowest, so it's probably, what I should say there then is that it's probably best to think in terms of the U value of the wall after you've insulated it, rather than the depth of insulation that you put on. Because if you put on 100 mil of one type of insulation, that may achieve the same thermal performance as 50 mil of a different type. So probably better to think in terms of U values. The lowest U value that we've had in our trial work was with 80 mil of wood fibre board. The U value of the wall was down to 0.19, and much lower than that you may start to get into the situation whereby there is insufficient heat getting into the wall to help moisture to move and allow that wall to dry out. So if you think of it in terms of U value, and if you think of that 0.19 as probably being around about the lowest that you would potentially want to go, so round about that figure, I would say.
Okay, excellent. Well, thank you very much. Unfortunately, we're out of time. Thank you to everybody who's come in and joined us today on the webinar. You can keep up to date on what we're doing. Oops, sorry, just flicking through a couple of slides that I should have gone through earlier. So we've got some future webinars coming up. There's one about smart homes. This is all to do with connected homes and smart gadgetry and things. That's on the 23rd of November, 1 o'clock. And then we'll be doing an energy storage webinar, home energy storage webinar in February. There's a link there as to how you can keep up to date with those. I hope you found this session useful. And finally, I'd like to say a huge thanks to Moses Jenkins from Historic Environment Scotland and to Julie Darling again for joining us today, sharing their knowledge and experiences. And finally, thank you to you for joining us. Goodbye.